In this problem, we're given a row of n joules, or I'll just call it an array of n joules, and each joule has a value vi, and this value can be anywhere between negative 10 to the 7 till 10 till the 7. So uh, on this array, we can do 4 operations. We can take out the leftmost joule in this array and then put it in our current hand. We can take out the rightmost joule and then put it in our hand, or we can take a joule from our hand and then put it on the left side of the array or on the right side of the array. And what we want to do is, after at most k operations, we want to maximize the possible sum of all the joules in our hand. So yeah, so due to an audio issue, I had actually solved this before, but I'm going to go over it, and hopefully the audio isn't choppy this time. So the first thing to observe is we can first do operation A and B and then operation C and D. So let's first focus on adding the joules, and then the last step will be, from our current hand, what joules can we take out to maximize our sum, right? So the first thing I did was you to read in the input. So we're given n, and I call k in my code as count because I use k in for loops. So I just called the k in this question as count, and then all the value vi's, right? So actually for the input, I created 2 arrays. One's called A, one's called B. And if you look at input 1, right, array A would store negative 10, 8, 2, 1, 2, 6, and array B would store 6, 2, 1, 2, 8, minus 10. So it is basically A but backwards. And the reason for this is I just didn't want to do any fancy math of like when looking at from the right side and the left side. So let's say I wanted to look at let's say I wanted to do operation A 3 times. So that would mean I would look at array A and I would look at the first 3 elements, right? Let's say I wanted to do operation B 3 times, right? Then I could just look at this array B and then look at the first 3 elements, right? Because that would be 6, 2, 1. So yeah, it's just for ease of coding. So then what I did was that I made a DP matrix, and the maximum value of n is 50, so I just let mxn be 55 to add some leeway. And then each container in this DP is a multi-set. Now why is this? So what I do is so dpij means that I do I operation A's and J operation B's. And to go over this again, operation A is when I take out the leftmost joule from an array, and operation B is when I take out the rightmost joule from this array, right? So if I'm dp 2, 3, that means I have done 2 operation A's and 3 operation B's. So in what I do here, if I plus j is less than n, then I will look at the first I elements from the right side and add that to our multi-set, and I'll look at the first j elements from the back, which is the same as looking at the first j element at the front of B, and insert that into our multi-set. And on the other hand, if I plus j is equal to or bigger than n, then we can just include this this whole array, because we can add all the elements in this array into our hand, right? So now we have an array of saying using dp what joules we can have into our hand at any point in time, right? And now we just have to go through all these entries in all our dpij's. We'll first figure out how many moves we have left. So we look at our value of count, which again is the value of k here, and then in dpij, to go over again, that means we do I operation A's and J operation B's. So overall, we would have done I plus J operations, right? And so the amount of operations we have left would be count minus I plus J, right? And if this is 0 or this is less than 0, which is caught over here, then we just move on to the next step, because we'll never reach that stage, because we have at most k operations, and if this is true, that means we have done more than k operations at this dpij, right? So now let's assume that at this dpij we have done less than or equal to k operations. So then we check the number of operations we have left, right? And then, so if dpij is empty, we break, and that just means our hand is empty at this point, and then we move on. Otherwise, we look at the very first entry in our multi-set. And now the main reason I made it a multi-set is because it's in order. So if I look at the very start of a multi-set, if that value is the lowest value in this entire multi-set. So if that value is less than 0, we can just take that out, because it's optimal to take away the largest negative value, right? So let's say you had one operation left and you had a multi-set of -3, -2, 1. If I take away -3, my final value is -1, and if I take away -2, my final value would be -2. Therefore, it's optimal to take away the largest negative value. So if there is a value that's negative, we'll find the largest one in this multi-set, and then we will take that out of this multi-set, and then we keep on doing this until we have no operations left. But if there is no number in this multi-set that's less than 0, then we're done, right? Because all these values are bigger than or equal to 0, so they increase the value of our hand. So then after we sieve through this multi-set, and then we take away all the values less than 0, then we calculate the sum of this multi-set, and then our answer would be the maximum of the answer we had before, and this value, and then we just output our answer. And with this code, it works. So voila.